Once you become familiar with control components, you can start to combine them together to create more interesting results. Like a game of Mousetrap or a Rube Goldberg machine. You can wire these components together to trigger an event only under very specific conditions. You can get quite creative with your use of control components and accomplish a wide variety of tasks. Eventually, you will hit a wall. You can accomplish a lot with these simple tools, but there will come a point when you need to move on to a more complicated coding language, like our script or block controller. However, in this video, we'll walk through a few examples of things that you can accomplish with the control components, as well as take a look at a few of the remaining components that we haven't seen yet. If you want to look at just one of these in particular, feel free to jump to the timestamp where each section begins. Here's a common scenario. You need to put the gain fader for a microphone onto a UCI, but that UCI is going to be operated by a human. And I don't know if you've ever met a human before, but they're mostly terrible. If you give them a fader, they are guaranteed to slam that fader all the way to the top, which is never a good idea. Instead, you can add a custom control with a level fader and customize the range of that fader. I'll restrict this one between -20 decibels and 5 decibels, since that's all the flexibility I think they'll really need. I'll wire this control to my original gain knob and add it onto the UCI. The user will never know the difference. They think they're maxing out the system, even though there's still plenty of headroom. Let's also grab the channel's mute button so the user can turn the microphone off. Since I've capped the fader's lower limit to -20 decibels, this bottom range is still audible. So it would be nice if this mute would automatically engage when the user turns the fader all the way down. For that, we can add a simple control function. Regardless of what range I've customized for this fader, I know that when it's all the way down, its .position parameter is 0. So I'm going to add a comparative statement with another control that will already have a position of 0. I'll add a toggle button, which by default is off, and select a control function of position equal. When the fader is at the bottom, its position is 0, which equals the toggle button that also has a position of 0. So that satisfies the conditions of the position equal control function, which outputs a 1 that engages my mute button. Now, when I pull the fader down, it automatically engages the mute. If I move the fader again, its position no longer matches the toggle button, sending a 0 that will disengage the mute. I could still manually engage the mute, but when I choose to move the fader, it will automatically open the mic again. We've made a simple solution to a simple problem. Buttons are great for binary behavior. When you need a 1 or a 0, they're perfect. But what if you want a button to output 2 other values? For instance, let's say we want a simple button that will toggle the gain of an audio player between a loud setting and a quiet setting. We don't want to mute it and unmute it, but instead toggle the gain's value between 5 decibels and -10 decibels. How can we do that? There are actually a lot of different ways to accomplish this. It all sort of depends on how your brain works. Let's look at a few methods. The easiest way I can think of is to use snapshots. You could use a 1 and a 0 to activate a snapshot load button, which can recall a saved value for your gain control. Let's create a new snapshot bank and associate our gain knob with that bank. Then we'll set the gain to 5 decibels and save snapshot 1, set it to -10 decibels and save snapshot 2. Then I'm going to grab a flip-flop. You may remember that its out and not out LEDs alternate based on the flip-flop state. I'll expose the control pins to load snapshots 1 and 2 and wire them to the flip-flop. Now I could put this state button on a UCI, giving the user a single button which has the effect of loading 2 different values to the gain knob. Let's look at another method. We could use a control router that directly sends a new value to the gain control. Here we have 2 custom knobs for our inputs, one set to 5 and the other set to -10. The control router determines which one passes forward. We can expose the control pins for selecting input 1 or input 2, and then use our flip-flop to toggle between these options. Alternatively, if you didn't want to use the flip-flop, you could use another button to activate the first router or snapshot option, and then use a control function to invert the position of that button so that when the button is off, it will send an on signal to the second router or snapshot option. These all have the same effect. It's just an example of the flexibility of these control components. Let's take a look at this control component, the status combiner. This is a rare component that only accepts status controls. You can find status controls in almost every inventory item or network-dependent component. You can combine them all into a single location by wiring their status control to the status combiner. At the top, the status combiner lists the worst status of all its inputs. If everything in your design is running properly, then it will say OK. But if I were to disconnect one of my peripherals, for instance, that device would disappear from the network and register as a fault. Since that's the worst status of all my devices, the status combiner will report the fault. You can customize a label for each input so it will tell you exactly which device is experiencing an issue. And if you want to ignore a particular device, then you could suppress its status, which will temporarily remove the problematic item from the status combiner's list of things to worry about. Finally, one of the questions I get asked a lot is whether we can add a password on a particular page on a UCI. While you can restrict an entire UCI to a user, requiring them to log in with a PIN number, there isn't a native way to require a code to access a specific page. Well, I'm going to start off by going to the Control Components branch of the Schematic Elements library and grabbing a pin pad, because we can solve most simple control problems with some clever combination of control components. The pin pad provides you with a numerical keypad on the left, which is exactly what we want to supply to the user on a UCI. Heads up, I'm going to jump in and out of emulation mode a lot while going through this. Firstly, to take a look at the controls on the right side of the pin pad's control panel. Here, you can enter any secret pin you want into this field. Here, I'll use the combination I use on my luggage. When a user inputs the correct pin and presses Enter, its corresponding LED will become true. So we can expose the control pin for pin match 1 and wire this to any number of components to initiate some sort of activity when the user enters the correct code. In fact, in the properties of this component, you can increase the number of possible pins to 16. So you could automate up to 16 different end results based on which code was entered. In our situation, we want to navigate the UCI to some sort of secret admin panel. So let's explore that. First, I want to add this pin pad on my UCI somehow, and my favorite method is to use a press and hold component. This is just a simple button that gives you two different trigger outputs. One if the button was held for a short amount of time, and another if the button was held for a long amount of time. And obviously, you get to set that time threshold. I'll hide this button under the logo on my UCI and change its graphic properties so that its fill color is transparent and it has no stroke, so it truly disappears. The employees will know that they can press and hold the logo for 5 seconds to make the secret pin pad appear. So let's make a new layer whose visibility we will control in just a bit based on the activity of that press and hold button. First, let's add the pin pad controls to that layer and adjust its appearance however we like. Next, we'll grab a UCI layer controller, but it's going to need a Boolean on-off state to control the layer visibility, and the outputs of the press and hold are just trigger pulses. So let's grab another control component to bridge that gap. I'll use the LFO we saw earlier. I'll expose the one-shot trigger control pin of the LFO and wire the long output of the press and hold to activate it. Then we'll need to expose the visibility control pin of the layer we built that has the pin pad, and then we'll wire the LFO's output, which is a Boolean true-false, to that layer. Then I'll turn off free run to make sure this only runs when I want it to, and I'll set the period to 10 seconds. In square waveform, that means its 50% duty cycle will output a true for 5 seconds and then a false for 5 seconds. And that way, when the user presses and holds the secret logo button for 5 seconds, they'll then have another 5 seconds to enter their pin into the keypad before that layer disappears again. All right, so far, so good. Next, let's build that admin page. One method might be to build this admin panel as an additional page of our UCI. I'll name it admin,
And if you're using this method, be sure to select your UCI in the left side pane, and then remove the UCI navigation tabs by changing their location to none, so the user can't access that page on their own, and also set Swipe Disabled to yes, to prevent them from swiping from page to page with their finger. I won't bother adding any controls to the admin page for the sake of this demo, but rest assured there are some super important admin controls here. With your admin page safely impossible to navigate to accidentally, let's look at the control panel of the actual touchscreen controller where the UCI is displayed. Let's go to its UCI/Screen tab, where you'll find the Page control. This can be changed while the system is running to navigate the touchscreen to a particular page. If I can control this control, I can change the page. I could use snapshots here, but I prefer to grab the selector component, which I think will be a little more elegant. Let's expose the selector 1 control pin, and we'll control that from the pin match LED output of our pin pad. Then let's expose the UCI current page control pin of the touch panel, and we'll wire the selector's output pin to control it. With everything wired up, we can define these selection options in emulation mode. I'll define the output for selection 1 as admin, or whatever exactly matches the name of our secret page. When the pin becomes true, the selector picks admin, and the touch panel would update itself accordingly. Keep in mind, if you're following along at home in emulation mode, that this page change is specific to the physical touchscreen itself, so you won't see it change here in Designer. Now, whenever you play with logic, be sure to think your way out of the situation you've made. We need to give them a way to close the admin page, as well as a way to reset the selector. So I'll accomplish both of these at once by placing the button for selection 2 onto the UCI and renaming it to say Close. Then we'll send the name of the main page to the touchscreen whenever the user presses this button, guaranteeing that the selector is reset. And let's use the activity of this second button to reset our system. I'll give it a signal tag of clear, and we can expose the clear control pin of the keypad and control it with that signal tag. This will make sure the previous pin entry is erased once the user is done. And we also want to make sure that whenever the system boots up, the selector is reset. Because if for any reason the selector is already accidentally on selection 1 when the pin goes high, then the selector output doesn't technically change, so there's no event, so it won't send that text string to the UCI, so it wouldn't change. So we need to make sure the system starts in a known good state, where the admin selector is off. Here is a clever little trick you can use anytime you need a particular control to start in a specific state. I'm going to grab a control function, set it to logic not, and wire it to the control in question. I'll leave the input of the logic not blank, which means when the system boots, it will resolve this logic function, and since the input is false, it will automatically flip that and output a true to my second selector control, making sure the system always boots to the main page and the selector is always ready for the incoming pin match LED. So we did all of that to control the page of the touch panel. But if you're using layers instead, well, then this logic may get tricky if you're trying to make a whole bunch of layers visible and invisible on your UCI. So this may be a great place to create a custom snapshot bank that controls the UCI layer selector. Save the state of the layers in the admin configuration, and then also in the main configuration, and control the snapshot's load buttons from your pin pad. Now, if you have many other things in your design that may also want to change these layers, and you end up using lots of logic ands and logic ors to keep it all working, you may be scraping the ceiling of what you should reasonably be doing with control components. And maybe it's time to upgrade and use the block or text controllers. But for simple automations, you can almost always find some combination of control components to get the job done without ever resorting to writing code. In this system, I'll bet I could also devise a little counter that goes up by 1 each time they enter an unsuccessful entry. If they try and fail 3 times, I could also trigger an alarm warning. send a signal to the lighting controller in the room. Aim the Q-SYS cameras to focus on their position. And command the network video peripherals to route the camera's mediacast stream to every display in the venue. All while sending a warning log message to the core manager, which will trigger activity via Q-SYS Reflect to call the police, etc.
The point is, you can have a lot of fun with control functions. I really do recommend that you spend some time playing with them, and hopefully these videos have inspired some ideas of your own. Feel free to challenge yourself by thinking of a problem you want to fix and devising a solution. If you find something that you can't do, this may be a time to start looking at the scripting or the block controller. Have fun playing, and we'll see you next time.